We build bridges, we erect skyscrapers. These towering structures are symbols of our progress and ambition, reaching towards the sky, defining our skylines and shaping our cities. But some of the most amazing feats of engineering lie hidden beneath the surface. Beneath our feet, a different kind of marvel exists, one that is often unseen and underappreciated. Tunnels, man-made underground passages, are marvels of human ingenuity. These subterranean pathways are a testament to our ability to adapt and innovate, creating solutions to complex problems. They connect cities, countries, and even continents. These hidden corridors facilitate the movement of people and goods, making our world more interconnected than ever before. Think about it. We bore through solid rock, carve paths under mountains, and create routes that defy natural barriers. The sheer determination and skill required to achieve this are astounding, and even conquer the ocean floor, creating pathways beneath the waves. These underwater tunnels are engineering marvels that push the boundaries of what is possible, all to create these hidden arteries of transportation. These tunnels are vital lifelines that keep our modern world moving, ensuring that we can travel and transport goods efficiently. Tunnels are more than just shortcuts. They are symbols of human perseverance and ingenuity, representing our ability to overcome challenges and create solutions that benefit society. They represent our ambition to overcome any obstacle, no matter how daunting. The construction of tunnels requires meticulous planning, advanced technology, and a deep understanding of geology and engineering. Of all types of tunnels, those built underwater are perhaps the most impressive. These structures are feats of engineering that require overcoming immense pressure, water ingress, and other unique challenges. They stand as testaments to our relentless pursuit of connection and progress. Underwater tunnels symbolize our desire to bridge gaps and bring people closer together, no matter the obstacles. These underwater passages are not for the faint of heart. They require incredible planning, cutting-edge technology, and nerves of steel. The construction process involves dealing with harsh underwater conditions and ensuring the safety of workers and future users. Let's dive deep into the world of underwater tunnel construction. We'll explore the challenges, the solutions, and the innovative techniques used to overcome the difficulties faced during construction, and the incredible stories behind these engineering marvels. From the initial design phase to the final construction, each step is a testament to human ingenuity and determination. Get ready to be amazed by the sheer determination and ingenuity it takes to build these underwater wonders. These tunnels are not just structures, they are symbols of our ability to dream big and achieve the seemingly impossible. Before we go underwater, let's get a handle on the basics. Tunnel construction is a fascinating and complex process that requires meticulous planning and execution. Whether it's for a road, railway or utility passage, the principles remain largely the same. Building a tunnel, even on dry land, is no walk in the park. It involves a series of well-coordinated steps that must be followed to ensure the structure's stability and safety. It starts with a clear plan, a detailed map of where the tunnel will go and what it will look like. Engineers and architects work together to design the tunnel, taking into account the geological conditions, the purpose of the tunnel, and the materials to be used. Then comes the excavation. This is where we get our hands dirty. Excavation is a critical phase where the actual digging begins. The type of soil or rock determines the excavation method. Big machines like excavators and tunnel boring machines are brought in to break up the earth. These machines are marvels of engineering, capable of cutting through the toughest materials. This material, called muck, needs to be hauled out. Efficient removal of muck is essential to keep the excavation process moving smoothly. It's a constant dance of digging, removing, and supporting. Each step must be carefully timed and executed to prevent any delays or structural issues. See, as you dig, you need to make sure the tunnel doesn't collapse. The deeper you go, the more pressure the surrounding earth exerts on the tunnel walls. This is where support systems come in. These systems are designed to hold up the tunnel walls and prevent cave-ins. Things like steel ribs, concrete linings, and shotcrete sprayed concrete are used to reinforce the tunnel walls. Each of these materials has its own advantages and is chosen based on the specific needs of the tunnel. It's like building a giant pipe, piece by piece through the earth. Each segment of the tunnel is carefully constructed and connected to the next, creating a continuous passage. And remember, ventilation and safety are crucial throughout the process. Proper ventilation ensures that workers have a constant supply of fresh air, which is vital in an enclosed space. We need to make sure the air is breathable and the workers are protected. Safety measures, such as protective gear and regular air quality monitoring, are essential to prevent accidents and health issues. Tunnel construction is a challenging but rewarding endeavour, requiring a blend of advanced technology, skilled labour and careful planning. By understanding the basics, we can appreciate the incredible effort that goes into creating these underground passages. Now, imagine taking all that we just talked about, the digging, the support systems, the ventilation, and putting it underwater. Yeah, suddenly things get a whole lot more complicated, right? Building a tunnel underwater presents a whole new set of challenges. First off, you're dealing with immense water pressure. The deeper you go, the stronger the force of the water pushing down on your tunnel. One tiny leak and it's game over. Then there's the issue of unstable seabed conditions. You might be dealing with soft clay, shifting sand, or even bedrock. Each material requires a different approach and specialized equipment. And let's not forget about the corrosive nature of seawater. It can eat away at your equipment and materials if you're not careful. But here's the thing about us humans. We love a good challenge. And these underwater obstacles, they just pushed engineers to come up with even more innovative solutions. That's what's so inspiring about this type of work. Section 4, Fighting the Forces, Water Pressure and More. Water pressure is a relentless enemy when you're building underwater. It's a force that never rests, constantly pushing and pressing against every surface it encounters. It's like an invisible hand pushing down on every inch of your structure, exerting immense pressure that can cause significant damage if not properly managed. To combat this, engineers have developed some pretty ingenious methods. These methods are the result of years of research, innovation, and trial and error. One way is to use a technique called compressed air tunneling. This method has revolutionized underwater construction by providing a practical solution to the problem of water pressure. Basically, they pump compressed air into the work area. This creates a pressurized environment that counteracts the water pressure, allowing workers to operate in a relatively dry space. This increased air pressure helps to hold back the water and create a dry space for construction. It's like creating a bubble of air that keeps the water at bay, making it possible to work on the structure without the constant threat of water intrusion. Another method is to use prefabricated tunnel sections. These sections are meticulously designed and constructed on land, ensuring they meet all the necessary specifications and standards. These sections are built on land, then floated out and sunk into position on the seabed. This method allows for greater control over the construction process and helps to minimize the risks associated with underwater building. It's like building with giant Lego blocks underwater. Pretty cool, right? Each section is carefully placed and secured, creating a strong and stable structure that can withstand the forces of the underwater environment. But it's not just water pressure we have to worry about. There are other forces at play that can impact the stability and integrity of the structure. There's also the issue of buoyancy. Buoyancy is the force that causes objects to float in water, and it can be a significant challenge in underwater construction. Imagine trying to hold a beach ball underwater. It takes a lot of effort to keep it submerged because it naturally wants to float back to the surface. It wants to float back up, right? This is the same principle that applies to underwater structures. Well, a tunnel can be like that too. If not properly weighted, it can float or shift, causing potential damage or misalignment. That's why engineers carefully calculate the weight of the tunnel sections and use ballast to keep them firmly in place on the seabed. Ballast is essentially heavy material that is added to the structure to counteract the buoyant forces. It's a delicate balancing act, but these folks are masters of their craft. They use their expertise and knowledge to ensure that every aspect of the construction is meticulously planned and executed, resulting in a safe and stable underwater structure. Section 5. Tunnel boring machines, underwater beasts. Now let's talk about the heavy hitters of the tunneling world, tunnel boring machines, or TBMs for short. These are the behemoths that chew through earth and rock like it's butter. And yes, there are TBMs specifically designed for underwater use. These underwater TBMs are engineering marvels in their own right. They're basically giant self-contained factories on wheels, or should I say tracks. They have rotating cutter heads with teeth that grind away at the earth. But here's the cool part. As the TBM bores through the earth, it also lines the tunnel walls with precast concrete segments. It's like a one-stop shop for tunnel construction. And talk about efficiency. Of course, operating a TBM underwater comes with its own set of challenges. You have to deal with things like water ingress, muck disposal, and the constant need for maintenance in a harsh environment. But hey, that's all part of a day's work for these underwater heroes.